Hi guys, welcome back to the shop. Well, I went out and retrieved one of these HP 608 units from the stack that I did a video on not too long ago. This is the 608C, and basically in this video I just want to do a will it work type video. Now you can see this thing is completely filthy. I mean, even the glass on the dials and the frequency dial was just very dirty. All the aluminum has got corrosion and dirt on it, so I just want to see if one of these things will work. I removed the 4 thumb screws from the back of it already, and I'm gonna go ahead and set the camera aside and get this thing out of the case. This thing stands 16 inches tall and it's 13.5 inches wide, but the big problem is that's from the back to the edge of this handle is 20 3/4 inches. So when you're using no big equipment like this, you definitely got to have space on the bench for it, because it takes up a lot of room. Anyway, let me go ahead and get this thing poured out of the case. Alright guys, I got the case off and looking at it, and I've already seen some things that, you know, kind of why I didn't want to power this thing up to start with. We look here, one hiding up here, and a big one here. Them old Bumblebee capacitors, they got to go. These things are usually always bad, and I would be a little hesitant to fire this thing up with these old paper caps in here, like a bunch of .01s. So 0.022 here. This one, and this one looks like .01s. And I'm noticing something else here. If you notice, there's a lamp socket down here, and that's supposed to be a lamp screwed into this, and it's not there. And that is a balance lamp for the modulation circuit, if I remember correctly. It's been a while since I've looked at the schematic, but I believe that's what it is. But anyway, it's X11 and the lamp is gone. It looks like it's broke off in there. Here we are looking at the back of it. We can see there's some more electrolytics here. These are screw-in type. There's 2 more over here, and there's a Bumblebee cap hiding here, and there's 2 here, and those are .01s also. But yeah, those Bumblebee caps they got to go. They can cause all kinds of problems right to start with. A few spider webs hanging around inside. Now on the bottom, what makes this thing so hard to move around is that on the bottom of this thing there's some wheels on both sides at the back, and that makes it so it'll roll in and out of the chassis. And we can see one of the electrolytic caps here. You can see it's probably an oil field transformer. This is our RF section. And if you look in the top, right here in the top of the unit, there's 2 clamps here. And what this is, it's normally a tool that is mounted here, and that's for taking out the RF power amps. It's a special tool they use to remove those. And in either one of them I looked at 4 of them instead of the case, just enough to look in there, and I do know the 4 of them is missing this tool. Also up here on top right here is another big electrolytic capacitor. Again, I'm not worried about those as much as I am those Bumblebee caps. Alright, so I got the broken lamp holder out, and they got this coil over this thing, and that makes it very difficult to remove the lamp when it's broken. But I got this out, so I'm gonna go ahead and get another lamp and put it in there. Okay, I got another lamp. This is just a 3-watt incandescent lamp. I see no numbers on it, and there's no numbers in the manual other than the HP part number. I should be able to screw this back on, be able to get a lamp in there, and all this does is just help hold the lamp in to keep it from loosening up and falling out, since it hangs upside down. There we go. And if you notice the tube sockets, all the tubes in here have spring clips on them that keeps the tube from working loose and falling out. So I'm gonna go ahead and replace these Bumblebee caps. There's another one hiding up here I didn't see, C11. That's also a Bumblebee cap. All the Bumblebee caps has been replaced. We got a .22, 1, 2, 3, 4, 5, 6, 7 .1s and 2 .01s. And I almost missed these because they were behind this board over here, and I pulled them out to replace them, and they're already cracked up. So these is done popped, and that was cracked down and around the end. So yeah, that's why we have to replace those caps. So what I'm going to do now is put this on the Variac, and I'm going to bring this up to voltage about an hour, hour and a half, a little bit at a time, and let those capacitors get reformed. Well, that's been about an hour and a half, and you can see we're at 121 volts, and at the moment everything is looking okay. So what I want to do is hook something up to this, and let's see if it's putting out a signal. Alright guys, I let it stay powered on for a little while longer. See no smoke, everything looks good. I'm going to, I've got a radio here. I've got it set to 10 megahertz, and we're going to set the signal generator at 10 megahertz and see if we get any signal out. Oh, we already get something. I'll keep that low. That's 0.4 on the meter. We got a bit over S9 on the radio. I see no modulation output. I'm going to turn the radio down. Let's see if we can get our signal level up. But it looks like the modulation meter is not working. clear it on up to 20 megahertz. And that would be on band B. Turn the attenuator right on down to 0 and full scale. I'll set it about S9. And it's right dead on 20. Now I don't know just how calibrated this is, because this is showing 40. But you can see just how touchy that is. Then you got your fine frequency adjust here. I could just watch the S meter and peak it. So this radio go up to about 30 megahertz or 29 megahertz. And that's 29 megahertz. Now that we do have a somewhat working unit, I want to show you some of the few controls. We have our main frequency adjust and a fine tune. Now on the D models, there's another control here that actually has a crystal calibrator built in it. This one does not. So you would need a frequency counter or spectrum analyzer or something that you could check this against, or zero beat it on a receiver to get the output frequency spot on. The way that I'm doing this is that I'm just peaking the frequency till I get the highest S meter reading on the ICOM over there, and that kind of gets you somewhere in the ballpark. But also on this unit, the RF output, you know, this is an attenuator. You have to get it calibrated. And to calibrate it, if we look at this meter here from output volts, right here just below the 7 is a little red arrow that you can just barely see it right there. Now I think you can see it better there, but there's a little red arrow. Underneath is a amp trimmer, and what you do, you adjust this until you're dead on that red arrow. Once you get that done, you go down here to the attenuator. If you want to set this for like 73 minus 73 dBm, this top scale is in minus, the bottom scale is in millivolts, and then microvolts. So if we want to set this for about minus 73, that would be 70, 1, 2, 3. Now we should be putting out minus 73 dBm, or it's about 49.5 microvolts. So if we look at our S meter on our ICOM, we can see it's just about on S9. So that's pretty close on the calibration on this thing. So again, you know, we on the modulation selector switch. We're on 1000 Hertz. There's 400 Hertz. There's a pulse and CW. CW is just a carrier wave. It doesn't, when you go to CW, it's not putting out any modulation. It's just pure RF out. So we're in CW mode. You notice there's no modulation out. It's turned wide open. It has nothing out. But however, in CW mode, there's not even a signal on the radio. So that could be a dirty mode switch, some resistors going out of calibration or whatnot. Could be a tube. Something I haven't even done is checked any of the tubes in this. So yeah, that's a problem. Should be a signal coming out, but it's not. I went ahead and cleaned the switch wafers, and sure enough, I got it so it works on CW. What I have noticed, the longer this thing stays on, the less output it is putting out. So I don't want to keep stressing it too much. We know that it's got to be gone through completely. Still, you know, we haven't, like I said, we haven't checked any tubes. We haven't checked any electrolytic capacitors. That could be any of that stuff. Could be bad. That needs to be, you know, checked and replaced. But you can see we're in the CW position. We're calibrated. We're at about minus 73 dBm. And we have an S7 on our meter. So we know that has taken care of the problem. And I can hear it going off frequency a little bit. So that means this is getting ready to start going down. Like I said, I don't want to keep running it until, you know, we do a complete full restoration on this unit. So one thing, you know, in the restoration we'll do is going to take the front panel off and move all the knobs. All the knobs and dials will go into the ultrasonic cleaner. But I just took some plain water with a little soap in it and started over this. You can just see how dirty and nasty this is. And just a little water with some soap in it. You can already see just how nicely that front panel is going to clean up. It's just coated with dirt and dust. So what I want to do is take this panel off, which means you're going to have to disconnect a lot of stuff and just scrub this thing down real good, and that thing will look just about new. I cleaned the meters and the dial face, the glass in them, much cleaner. You know, the only thing I've done was just wipe these down with some soap and water. And we go in there and polish them with some automotive wax or something, this black trim, and this front plate is going to look pretty good. So one more thing I wanted you guys to see before I finish up this video. I got one more screw left. This is the RF amplifier tuner, RF oscillator tuner. We'll remove this last screw here. I just thought it'd be interesting to show the inside of this section. And there we are. You can see this is our RF oscillator. This is part of your attenuator tube that goes out the back. There's actually a slug that runs in and out. You can see our band coils, and as we turn the band switch, you can see it selects each coil and each RF device. Now the funny thing is, this one is bent, and I don't think it's supposed to be that way. I'm not sure how it would have got bent like that, not unless the screw itself is bent and this thing got hung up on something. I'm not sure what. But you can see if I go here to A core, that's the core that is put in place, and on A that is 10 to 21 megahertz. And then as you move closer, you see it gets less and less windings. This is actually here the D core, which is 95 to 215. That's just a 1 rep core. And then the 215 to 480 is just actually a bent piece of wire up there. But you can see these little tabs here, they make contact up in the top. But I'm going to have to check out why this one is bent. Maybe that's the way that they had to do it to tune it. I'm not sure. So guys, I did go ahead and check some of the tubes in there. Some of them I got to pull out and check with my Hitchcock. But for the main part, all the small tubes checked out good. So I know there's going to have to be some resistors placed, and we're going to have to look at the electrolytic capacitors and see which ones of those need to be replaced. Now I'm not going to replace all of them because that's going to get kind of costly. And like I said, I don't need these units. I'm going to just try to get the ones that I can up and working, and clean them up and see if I can find some homes for them. Because like I say, I don't need them. I do know of a couple of people that could use some signal generators, and I think one of these would be perfect for that guy. But yeah, that's what we'll do sometime here in the near future. Like I say, I got to get these things out of my way. They're filling up the shop out there. So we'll see how that goes. Anyway guys, that's going to be the end of this video. So be looking for some more videos out soon, and we'll see you in the next one. Bye now.